A boy is trying to open a stuck door. He pushes it at a point 0.83 meters from the hinges with a 250 Newton force, directed 20 degrees away from being perpendicular to the door. The hinges are the natural pivot point. Determine the torque does the boy exert, and how could he exert more torque? So for this problem, let's make a simple diagram. For example, this is the door at top view, and here's the hinge, and here is the radial source. So the boy is exerting force at 0.83 meters away from the hinge, which means dito. And kung ito'y perpendicular, he's exerting 20 degrees away from being perpendicular. So this is 20 degrees. And ang force niya is 250 Newton. The formula for torque is equal to the radius times the perpendicular force. But ang force natin kasi dito is not perpendicular. It's 20 degrees away from being perpendicular. To get the perpendicular force, we can simply get the vector component, wherein perpendicular force is equal to force cosine 20 degrees. And by substituting, we have perpendicular force is equal to 250 newtons times cosine 20 degrees. And we're going to get the value for perpendicular force, which is 234.92 Newton. So now that we have a perpendicular force, we can now substitute. Torque is equal to, the radius is the 0.83 meters multiplied by 234.92 newtons. And we're gonna get the answer torque, and that is 194.98 Newton times meters. And this is the final answer for this problem. Now, how could he exert more torque? Torque depends on how hard he pushes, or how far he pushes, or at what angle. So, kung gusto ng boy to exert more torque, he could either push harder, or rather exert more force, he could also push farther sa mas malayo dun sa hinge, push farther from the hinge, or just simply push exactly perpendicular. And these are what could make the torque he exerts greater.